Hello, everyone. My name is Jack Kushnerek. This is my individual video project on Fileless Malware, how adversaries go undetected. The class that I'm doing this for is Cyber 442-50 Cyber Operations at Metropolitan State University, and my instructor is Alex Hepp. Before we begin, a little disclaimer. This presentation and video are solely for educational purposes. I'm not liable for any damages that could be caused using any of the demonstrations shown. What is fileless malware? Also known as living off the land, non-malware, or ephemeral attacks, fileless malware is a cyber attack technique where cybercriminals use native legitimate tools within the victim's system to sustain and advance an attack. These attacks do not require an attacker to install any code or scripts in order to perpetrate the attack, hence the name fileless. Typical malware detection tools like antivirus software rely on signatures. Fileless malware provides no signature, therefore antivirus software is useless against it. The legitimate tools used with fileless malware are known as lolbins and have been extensively cataloged and reported on for years. This type of attack has been around for at least 25 years. Fileless malware continued. Many common living off the land attack vehicles such as WMI and PowerShell are in the victim network's allow list, which makes for a perfect cover for adversaries as they carry out malicious activity. These tools will be discussed at length in later slides, but few examples include PowerShell, WMI, Windows Registry, and CertUtil. There are more than 100 Windows system tools that can be leveraged and abused by lolbins. Why do attackers use living off the land techniques? Because of the stealth involved in living off the land attacks, they are notoriously more successful at extending dwell time than traditional attack methods. Extended dwell time equals more thorough extraction capabilities and higher value rewards for attackers who can go undetected. In general, living off the land attacks are more effective than traditional malware. These attacks are easily accessible, capable of evading detection, highly adaptive, and supportive of automation. The combination of the above-mentioned factors create a perfect recipe for an attacker's playbook. Listed here are commonly abused Windows tools. We will also go into these in more depth in the following slides. But first, PowerShell. Its legitimate purpose is admin scripting, and the malicious use, it can be used for remote command execution. Next is WMI, which is Windows Management Instrumentation. Legitimate purpose is used for system management, and it can also be used for lateral movement within a system. Next is regsvr32, which is used for dynamic link library registration. It can also be used for script execution. Next is registry, which is used for config storage and can also be used for persistence. First up, PowerShell. PowerShell appears in 71% of documented living off the land cases. PowerShell is also the main vehicle that we're using for the demonstration. Attackers can use it to download payloads, run code in memory, disable defenses, add and remove registry values, obfuscate commands, and move laterally. Next is WMI, Windows Management Instrumentation. Often used for remote management, it enables remote execution and persistent code execution via event subscriptions. Event subscriptions can be enabled to trigger actions when certain system events happen, such as a user signing into a workstation. WMI can also be used to disable things such as Windows Defender, leaving a system vulnerable to compromise. Next is CertUtil. To describe this, we're going to use a case study that's also exemplified in my demo. Oil Rig, an Iranian state-sponsored group active since 2014, built much of its tradecraft around abusing tools that no security team would think to block. Their campaigns use CertUtil, a native Windows certificate management utility, for file transfer and decoding base64 encoded payloads, and pulling them from attacker-controlled infrastructure, all without triggering standard controls. An example of base64 encoding will be shown in the demo and can be used within PowerShell as well. Next is the fileless attack lifecycle. First, the user would receive a spam message with a link to a malicious website. The user clicks that link. The malicious website loads Flash, which has known vulnerabilities on the user's computer. Flash opens the Windows PowerShell tool, which can execute instructions through the command line while operating in memory. PowerShell downloads and executes the script from a command and control server, and the PowerShell script locates and sends the user's data to the attacker. This attack lifestyle can vary. This is just a very simple explanation of what this attack process looks like. And this is by no means the hard and true way that every single fileless attack lifecycle goes. Next up will be the demonstration. This demonstration will show how PowerShell can be used for reconnaissance, how PowerShell can be used to encode and then execute commands, which will exemplify the Iranian case study that we just went over, and then how PowerShell can be used to set and remove registry values. These are my sources, and thank you for tuning into this first part of my individual project.
Hello, everyone. This will be the first part of my demo. So the first thing we're going to do is we're going to show how PowerShell can be used to gather system information for reconnaissance. We'll go through a couple of different commands of PowerShell, just pretty basic things. But all of these commands can be used to gather information about the system, gather information about the network, current processes running, things like that. And all of these commands are fairly common. They're fairly simple commands that pretty much anybody could run on the system. This activity would not look any different from a normal regular user. So the first thing we're going to do here, we'll go ahead and get PowerShell booted up. After we have PowerShell here, first thing we're going to do is we're going to run the hostname command. This command is going to tell us the name of the computer itself. So as you can see, this virtual machine's name is going to be desktop-OCHFJ78. So that can be useful just to get the name of the computer that you're working on. We can also do who am I to see who is a currently signed in user that is using this device. As we can see, user, this shows the computer name along with the username. And a later command will show the full username. It'll show the email that I used to create this virtual machine. We can kind of go from there. So the next thing we'll want to do if somebody wants to gather reconnaissance, type ipconfig/all. I did disconnect the network adapter from this virtual machine to not show my IP address. But this command, what it will show, will display exactly what you could see if it's connected on some sort of corporate network. So go ahead, we'll press ipconfig/all. As you can see, it shows the host name here. If you were connected, this says media state disconnected. If I was connected to Wi-Fi, there would be another option here. With the different Wi-Fi options, it would show if the IP was gathered from DHCP, it would show DNS servers, things like that. For this Ethernet adapter, if it was plugged in, it would show an IP address. It would show the provider. Well, actually, it does show this provider right here, hsd1.mn.comcast.net. So this command can be useful to gather information about the IP, the network that you're working on. Once you can gather an IP address, you can run further tests using tools like Nmap, which is a network mapper, to discover open ports for different vulnerable applications that may be running on the network. And from there, attackers will slowly keep creeping into a system. Again, these commands can also be run remotely. A little bit later, how to encode using base64, a different command, and just run the encoded line of text, and that will run a system. So continuing on with this demo, the next thing we'll do is run get process. This will show us exactly what processes are running on the virtual machine currently. As you can see, there's a whole bunch of things that come up. If we look through this, we can see the different PowerShell processes that we're running right here. We have different window processes. When I was doing some tests with this, I was using the code application to sort of pull that up. We'll also use that to pull up different applications using run commands from PowerShell. So the next one, this last one is probably one of the most useful commands that I've found for gathering reconnaissance and just different information about the system itself. Use the system info command. It's going to pull up a whole bunch of stuff. This will show us the name of the computer, the OS that it's running, the version, manufacturer, configuration, build type. This is the registered owner, so this will be the email that I use to create this account, or create this virtual machine. It'll also tell us how many processors, system type, and then all of the virtual allocated memory that have applied to this virtual machine. At the very bottom, it does say a hypervisor has been detected. What we're running this on is VM or Oracle VirtualBox, so that's going to be a level 2 hypervisor or a type 2 hypervisor, which means it's not running on bare metal, it's running on top of the operating system that I currently have installed on my computer. So yeah, those were 5 quick commands that we can use to gather system information. In just a second, we will go over a few different things, and we'll continue to show how PowerShell can be used within different fileless malware attacks. So thank you.
Hello, everybody. Give me one second here. We're going to get set up for our second part of the demo. For this part of the demo, I'm going to be showing how we can use base64 encoding to go ahead and encode just a basic PowerShell command. These type of commands can be used to obfuscate what attackers are doing. When you're using encoded commands like this, the process often shows up differently. It doesn't show the exact command. If you're looking at it in something like Process Explorer or the Task Manager. So what we'll do here, so I'll go ahead and open up the PowerShell script that I made. As you can see, we have a couple different commandlets here. We have the command, which is the actual command that we're going to be using. This says cat. And we're going to be looking in the directory of users, cyber4, documents, and then this encoded.txt file. And if we go back to this folder here in File Explorer, we can see exactly what this encoded.txt file will say. So after we use the cat command, otherwise known as concatenate, we'll be able to see this text displayed in the PowerShell window. So we'll go back here, go ahead and open up this script one more time. So basically what we're doing here, this is the command we're telling PowerShell to execute. We have another command titled bytes. This is going to be the actual encoding command. It's going to take in the commandlet or function. It's going to take that in. It's going to rename it bytes, system.txt.encoding. We're going to encode it into unicode.getBytes. After that, we have a command called encoded. This is going to convert this encoding to a base64 string. So when we run this in PowerShell, it's going to output a very long string of letters and numbers and symbols. After we have that string of letters, numbers, and symbols, we can go ahead and type in a different command into PowerShell called encoded command. And basically, PowerShell will take that encoded command and turn it back into its original command and then run that. So we'll go ahead and do that here. Give me one second. We'll go ahead and close out of all of these. We'll go ahead and open up PowerShell. After we get into PowerShell, we're going to have to navigate to that folder that we were just in. So I want to go to C, users, cyber4, and documents. From here, you can go ahead and run that script that I created. So that script is titled psencoded.ps1. We'll go ahead and run that. This long string of letters, numbers, and symbols at the end is going to be the encoded command. So that script that I just showed, after successfully running that, it's going to output this string of letters, numbers, and symbols. We'll go ahead and copy this. And then we'll type PowerShell. You can see coded and spell right. Encoded command, and then we will paste that long string of letters and numbers in here. After we do that, we can go ahead and hit enter. And as you can see here, we have successfully executed an encoded base64 command in PowerShell. As mentioned earlier, attackers can use encoded commands to obfuscate their activities and throw security professionals off their trail. So especially in different attacks like living off the land and fileless malware, attackers are really trying to extend their dwell time. They don't want to make themselves known on a system, and we'll see that with a lot of the different APTs. If you've ever read a report on APTs, you'll notice that some of these APTs have been within the companies for months or even years before they were detected or before they exfiltrated data. Obviously, this example with PowerShell is just a very basic way to wrap your mind around the fact that a lot of these attackers are using pre-built system tools. So these system tools are not going to have malware signatures. Antivirus isn't going to catch things like this. And attackers will be able to extend dwell time and continue attacking and stealing private corporate data. All right. So that is that. The next thing we're going to do, Hello, everyone. Welcome back to the third and final part of the demo. For this portion of the demo, what we're going to be doing is showing how to add registry values to the Windows registry through PowerShell. So just kind of a quick overview. If you're unfamiliar, the registry is where your operating system will go to verify certain information. So things like applications, different startup applications, the users that are currently signed into the machine, things like that. So different like key values that your computer and operating system use to verify that what you're doing is like allowed and acceptable. It's arguably it's one of the most important things in your operating system, and the fact that you can add values from PowerShell kind of makes it a little bit dangerous. That functionality is incredibly useful for administrators, different systems administrators, network administrators, things like that, to be able to add those values and make their life a little bit easier. But what comes along with easier life for sysadmins is often easier tools and access for malicious actors that are making use of living off the land malware. So to get into this, we're going to go ahead and open up PowerShell again. Once we have PowerShell open, we are going to use a command called new item property. This little asterisk, or not asterisk, this little like single quotation mark there. Once we have that, we can go ahead and set the path. The path is going to be the path within the registry for where we want to set this value. For the example that we're going to be doing, we're going to create a new startup application. We're going to use the calculator app, and we're going to enable that to run on startup. And then just to show you, okay, second, so we're going to close out of this. Go ahead and open up the task manager. If we go here to startup, you can see that there's the only things that are ready on startup are Microsoft OneDrive and the Windows security notifications. After we create this registry value, the calculator application is then going to show up in the startup options menu there. All right, so the first path that we'll set is going to be HKCU. Then we're going to go to software, Microsoft, Windows, current version. Continue on with that. We're going to name this demo persistence. Then after that, we're going to specify the application that we want to start up, which in this case is going to be calculator.exe. After we do that, we can go ahead and hit enter. It's going to show us what we just created. We can go ahead and minimize that window. We'll go back down to the task manager, open up the startup menu. You can see that calculator is now enabled for startup. And then to get rid of that, we can do just about the same thing. So instead of new item property, we're going to do remove item property. Path, which is the path that we just set. So that's going to be the same thing, HKCU, software, Microsoft, Windows, current version. Then we're going to specify the name, demo persistence. We can run that. After we do that, we can go ahead and minimize PowerShell again, go back into Task Manager, look under Startup, and we can see that that application has now been removed from the startup menu. So just kind of to go over these things again, malware commonly abuses run keys, creates persistence after reboot. So if you make changes in a registry, even if you reboot the system, those changes are still there unless you physically go back and change it or remove the run item that you just set. This was another example. So we use PowerShell a lot throughout this demo, but this example goes to show that you can also use different features within Windows, which were talked about earlier in the presentation. And an example of that would have been the registry. So yeah, that is my demo. I want to thank you all for tuning into this. Thank you for watching my individual video project, and I hope you have a great rest of your day.